Today we'll be talking about the challenges in the embedded system, right? The challenges involved in design of an embedded system. So before starting the design, we should ask ourselves some questions. So how much hardware do we need? How do we meet the deadlines? How do we minimize the power consumption? How do we design for upgradability, and does it really work? Right? These are the very important questions we should be asking to ourselves before going to a design, right? Now, these questions or the answers of these questions will be based on the requirements of a system, right? Now, what are the requirements of a system that will get from that will be that will receive from like to whom to whom for you designing the system, right? So let's take an example of a data logger, and we want to log the data of a temperature and humidity for, let's say, this classroom, right? Now, as we just need to receive the data from the sensors, we have to sense the data by using sensors. The sensors may be analog or digital and will be providing data, right, to the internet, or we can say a server which is connected to our system through internet. So we'll be sending data to internet and finally to our particular server, right? Now, how do we going to evaluate, or how do we going to find the answers of these questions regarding our example, right? Yeah, this is, you see, this is a Arduino Ethernet shield, and obviously there will be a Arduino beneath it, right? Then I'll be having this device. You know, this device we have seen in the last lecture. This is STM32, which is based on ARM core, right? Then we have this device, or this hardware even. It's called as BeagleBone Black. This is also having the Ethernet connectivity, right? USB, and a big ARM-based processor, right? Along with that, I have this is a small Raspberry Pi called as Raspberry Pi 0W. You see, there is also Wi-Fi connectivity, Bluetooth connectivity, along with a memory card and a big ARM core-based processor. Or I can use this bigger Raspberry Pi. This is having again ARM core processor, right? And Ethernet chip, gigabyte port, USB ports, right? HDMI port, even audio jack, and all those things. And the question to be asked is, how much hardware do we really need for the application, right? Now, if we are talking about the embedded system, then the thumb rule is to use the hardware which is really needed, right? We should not use extra hardware, right? If we use the excessive hardware for the development, it will definitely going to consume more power, right? So if we use the more hardware, if you use more hardware, right? If we use more hardware or unnecessarily high computing power, which is not demanded by the requirement, right? But still, if we're going to use that, it is going to utilize much more power, and it's definitely going to increase the cost, right? Though there will be a scope for upgradability, and we won't miss deadlines, right? We'll talk about the deadlines in a minute. But as it is going to consume more power, if the application is battery operated, as an example, since we are using a data logger, which is almost a battery operated applications, so in that case, if I'm using a Raspberry Pi and that kind of hardware, it definitely not going to work, right? So we have to understand the requirements very properly, and we need to take a decision about selecting the hardware, right? So let's understand the requirement. My requirement is, you can note it down if you want. My requirement is, I should be having a 2-channel input. That means one channel is for temperature, one channel is for humidity, and I'll be sending data to the internet, right? This is my first requirement. My second requirement is, the device should be battery operated, and it should run at least 30 days on a single charge of a battery, right? That means the battery life for a single charging should be around 30 days, right? These are the only two requirements I'm having for the device. So can you tell me which hardware I can use? You can comment, you can talk. Come on. Which hardware you are going to select? If I have given you the two requirements, okay, I'll repeat the requirements. A device should be having the two channels, one for temperature, one for humidity, and it should be able to send data to internet server, right? Second requirement is battery life should be of around 30 days. The device should work for 30 days on a single charging of a battery. Can you tell me which hardware I'm going to use?
So from once you showed us, or like any hardware?
Or you can again consider Node MCU. I forgot to bring it here. Okay. I hope you all have seen Node MCU. Or just a minute, I'll just bring it. You can see this in the video. This is a Node MCU I'm having. Right. Right. So can you tell me which hardware should I use? See, design process is all intuitional, right? There is no hard bound or fixed protocols for designing. It is based on the intuition of a developer. So you should be able to create your intuition based on the learnings, right? So can you tell me which hardware should I use?
So ESP32.
ESP32. Any more? Any more options? Again, anyone?
ESP8266 can work also.
ESP8266. Again, can't I use I mean Arduino along with the shield, Ethernet shield?
So it will have more hardware, and so the battery life will decrease.
Battery life will decrease. Again, good one. What about the cost? Have you thought about the cost?
Yeah, cost will increase too.
Cost will also increase, right?
Yes.
Yeah. So see, the suitable, like let's come to a conclusion, and let's give the reasons why we are coming to this conclusion. First of all, about Raspberry Pis. Now, though the Raspberry Pi is having higher computational power, for this data logging application, we need not. I mean, we don't need that much of computing power, right? Because we are not processing the data on board, right? You should understand the hardware first, right? Raspberry Pi is very computationally efficient. It can process the hardware on board and it can develop some algorithms too. Now, since this is based on the operating system, right, we can even code in Python about the algorithms that can process the data and can give you the just inference out of the data, right? मतलब उसमें से वो डेटा से एनालिसिस करने के बाद उसमें से एक इन्फ्रेंस क्या निकल रहा है वो रास्पबेरी पाई दे सकता है बट दिस इज नॉट पॉसिबल विद Arduino or ESP8266, right? This is very good. But does your application need that kind of inference? No. Our application just need uh, data to be sensed and sent to the internet server, right? So in that case, we does not need that much of computing power. So let's ignore those hardwares. That Raspberry Pi we are going to ignore, right? Next thing, do we really need? Do we need this ARM-based STM32 board? Now this is having quite a good power than the ESP as well as Arduino. But if you see, we need an internet connectivity on board. Otherwise, if you are going to use the external connectivity like the Ethernet shield in Arduino, it is going to cost us more. So what we are going to do, even though using STM32, that means ARM board, a small ARM board, it is going to cost less. It is just a 300 rupees board, but it does not have internet connectivity. So we need external connectivity for such kind of boards, right? So this is as good as Arduino without Ethernet shield, right? And that's why, since we are near, since we are going to need an external connectivity, this is kind of going to increase the hardware cost and hardware bulkness, right? So let's ignore this one as well. So we are remaining with the Arduino shield, Arduino along with this Ethernet shield and our node MCU or ESP8266, I can say, right? Now, how to choose between this? The another parameter comes in is a cost. If we consider the cost of Arduino as well as this Ethernet shield is going to cost more than 1000 rupees, right? But if you think about the, a node MCU itself, it is going to cost 400 rupees only or less than that. And it is having onboard connectivity as well. So it is very good for such applications, isn't it? But what about upgradability? Now let's, where is my pointer? Yeah. What about this point? As soon as we come to a conclusion of a node MCU, and if someone says, I may need one more channel in the future, right? Currently, we are having two channels, that is temperature and humidity. But what if I need one more channel in the future? And let's say I may need an extra analog channel in the future. Okay, let's be precise about that. Currently, node MCU, what you see is having only one analog pin, that is A0, right? Have you seen the pin diagram of node MCU, guys?
Yes, sir.
Yes. Seriously, guys, have you seen the pin diagram of node MCU? Or should I show you? Let me show you. Let's just share my screen first. So I'll just go here and node MCU pinout. Okay. So if you see this one, I hope you are able to see this. Yeah. Now if you see this one, there are many GPIUs present. Almost 16 GPIU pins are present, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 GPIU pins are present. But if you see the ADC, this is the A0 pin, right? ADC 0 pin. This is the only one ADC pin present on this board, right? Now, only one ADC pin means it can only accept, it can only accept one analog input and not more than one analog input, right? So if I'm talking about upgradability and I may need one more analog input in the future, I should be very careful selecting this device. Isn't it? Are you agree with me or not? right?
Agreed, sir.
Yes or no? Yeah. So I mean, like we have to be very sure about the upgradation of a system. That means we are not going to upgrade it, or it will be very difficult to upgrade the analog pin, right, of this. I mean, of this our data logger, right? So if we select this node MCU, our system will be with a constant of only one analog sensor, whereas we can give more than one digital channel for this, right? So this is about how we think about the upgradability and the power consumption. Sorry, upgradability and the hardware required. Now let's talk about the next thing, which we called as the deadlines. Okay. Now let's talk about the deadlines. Now, what is meant by deadlines? Deadlines means in case of time critical systems, listen this very careful. In case of time critical system, the output provided by the system should be in a particular time window, and we called them as a real time embedded systems. Similarly, sorry, is someone talking? Someone asking question or what? Yeah, okay, fine. Guys, please mute your mic. Guys, kindly mute your mic. Yeah. So when we talk about the deadlines in a time critical system, we need output from the system in a particular time window. If you miss the window, it is going to create a very catastrophic effect, right? Similar thing is, I mean, how can we achieve the speed then? We can increase the clock frequency of a particular device, right? Now again, the clock frequency which is used to meet the deadlines and the power are related. Okay, this is very important, guys. When we increase the clock frequency of any microprocessor or microcontroller, it is going to utilize more power. Okay, this is a very important statement. Now why this is going to happen? If you think about the chip designing, this may not be the topic of discussion, but let me tell you, this is very important. When we design the chip, right, chip is made up of CMOS, or simply let's consider a very generic term as a transistor. Okay, and whenever there is a switching in the transistor from saturation mode to cut-off mode, or cut-off mode to active mode, or active mode to saturation mode, whatever, when there will be a switching, there is a power loss. Okay, and that power loss is considered as a power dissipation. So if we are increasing the clock cycle, the circuit inside the chip is going to like do more switching, right? Because based on the clock cycles, so it will consume more power. So we have to also consider the deadlines and the power consumption. There is a trade-off, right? So we have to understand the deadlines very properly. Do we really need that kind of time critical systems, right, as far as our data logger application is concerned? Obviously no, as we are sensing the data and sending it to our internet server, which is the temperature and humidity data, which is not going to change abruptly in a second or minute. The parameters that we are sensing, which is temperature and humidity, is a very slow parameters that are almost constant over hour, or almost constant over a 10 or 15 minutes window. So we need not to worry about the time criticalness of a system. So what we are going to do is we are going to make the clock frequency very less, so that it would utilize minimum power, right? This is one thing. Then we'll talk about the last question and the very important question: does it really work? Okay, even if we considered the 4 above questions and we tackled all these questions, all 4 questions, the most important question remains is, will that going to really work, right? So this is how, like, we do the testing and all those things to ensure that its reliability in working, right? Now the thing is, why we are facing these challenges in the design, what are the reasons behind the challenges, is our next slide. So first thing, what are the limitations we have, and because of that we'll facing the challenges. The first reason is the complex testing, right? It is very difficult to test embedded systems, right? Because every time when you go for testing, you may not be having a proper setup. So that is one thing. The second reason why we are facing challenges is limited observability and controllability. Now what this means is, let's say you have developed a data logger, and let's say instead of a temperature, let's say the current temperature is 30 degrees, so it is not providing 30, it is providing 35. Okay, but as this device is not having any kind of keyboard, any kind of mouse, any kind of UI or user interface, not even the LCD, it is very difficult to analyze what is going inside this device. Okay, and if the system is real-time system, then the difficulty become increases, because we cannot hold the system, right? It's working real time, so you cannot hold it. So again, the limited observability and controllability is going to make the challenges more critical. Then the next point is restricted development environments. Now, while developing the system, we are very limited with the resources, right? We'll be having only, let's say, the programming languages. We are not able to see the internal working in our development environment as far as this small devices like Node MCU, Arduino is considered. Like in Arduino, the things are again very much wrapped. For example, जैसे हम Arduino open करते हैं तो आपको सिर्फ ऊपर की लैंग्वेज दिखती है, उसके अंदर की लाइब्रेरीज, रजिस्टर सेटिंग्स, ये आपको नहीं दिखता है, right? So it is a restricted development environments. So that's also make the things difficult. Then the lack of necessary flexibility for running applications over embedded systems. Exactly. Just now we have said it is very difficult to upgrade because of the lack of hardware, right? We are not flexible enough to develop or to configure one of the pin as analog pin again, as we are having only one pin. And if I want another analog pin, I'm not flexible enough to develop another analog pin in this node MCU. So this is kind of restricted hardware, and there is a lack of flexibility. Okay, then again, the security crisis in embedded system design. Your PCs, your laptops, or even your mobiles are having firmwares, or we can say the firewalls. Okay, the firewalls, all antiviruses, those take care of the attacks from the intruders. But whereas embedded system as such is not having any kind of firewall or antivirus kind of thing, they are very prone for the attacks. In 2000, like, I don't know the year, but what happened, I'll tell you the case study. The security cameras were hacked by one hacker, and the Twitter account was hacked by using security cameras. Okay, I'll give the details about this on our WhatsApp group. So by attacking a Twitter through CCTV cameras, the Twitter was hanged for 2 days, right? The attack was DND, denial of service. Okay, so it is happened in 2016 or what? But I'll tell you the specifics. Okay, so that is the most concerned thing as far as the security is concerned. So very less secure systems are there as far as embedded systems are concerned. Then the next point is inadequate functional safety or safety critical embedded systems. Now these embedded systems are developed to control from point to point. It will be controlling the more like bigger electromechanical systems, or it will be acting as a sole controller for a particular system. So in that case, the functional safety is very much important. Now functional safety is something the functions what we have developed inside a particular embedded system should work very properly, right? And if that does not work properly, what safety critical issues is going to create? That is what functional safety is all about. So we have to very much careful when we are going to deploy an embedded system for bigger electromechanical systems, right? The last point, and which is very important, is increased cost. As we are going to, as if we, I mean, like need more time, and I mean, like if we invest more time in development and the testing and all those things, it is going to increase the cost of a system, and also a time to market. Time to market is a very much important issue if you are going to deploy your system as a product, right? If I'm developing some product today and if I'm not deploying within a time window, then other such products may come into a market and it will going to create a very problematic situation for your product, right? So this is the points. I mean, these are the 7 points which are the reasons behind we face the challenges in designing of an embedded system.